So we are going to discuss about speed of transverse waves on a stretched string. So in stretched string, the speed of transverse waves on a stretched string is the rate at which the wave propagates along a string. Consider this as a string. So this is a string and the waves are propagating along the string. Okay, and this waves on the string will depend on two factors. First one is restoring forces. The restoring forces is the force that brings the displaced portion of the spring. So if you are considering this as a string, so the force that brings the displacement portion of the spring back towards the equilibrium position. So this restoring forces will arise due to the tension of the string. So this restoring forces will arise due to tension of the string. And next is inertial property. So this inertial property of the system refers to its resistance to changes in motion. If the string is displacing like this string will show some resistance. So that is called the inertial property of the system. In case of transverse waves on a stretched string, the inertial property is determined by this linear mass density. Linear mass density is represented as mu, which is mass divided by the length. Mass of the string divided by the length of the string. And this speed of transverse waves on a stretched string, that is derived from Newton's second law of motion, which is F is equal to ma. So we are going to consider the dimension for linear mass density, which is mass by length. So we can write mass, so this length we can write it like this, L power minus 1. And the dimension formula for tension of the string is T is equal to m L T power minus 2, which is similar to force, dimensional formula of force. Next we are going to combine the above dimensions to get dimensional formula of speed. So we are dividing this tension by linear mass density. We will get the dimensional formula of velocity. So using dimensional analysis, the dimensionless constant cannot be obtained. So the exact formula cannot be obtained because the derivation is out of scope of this book. Therefore, this velocity of the stretched string in transverse waves is given by V is equal to C into root of T divided by mu. So this T represents the undetermined constant of dimensional analysis. So through dimensional analysis we cannot able to obtain the value of this constant. So but in exact formula the value of C will be 1. So if you are substituting the value of C as 1, the speed of transverse waves on a stretched string is given as V is equal to root of T by mu, where this V depends on the properties of medium T as well as mu. And this capital T, tension. So this property of stretched string is arising due to the external force, and in this property it does not depend on the wavelength of this velocity, will not depend on the wavelength or frequency, and the frequency of the waves is determined by the source of disturbance.